So we are going to have a session on continuous deployments using Salesforce packages. I'll be taking you through the session specifically for unlock packages. And you might have gone through the deployment phase where you have used chain sets and and scripts and other tools to do this. But we are going to go through a technique where it will be far easier and more seamless and a more elegant way to do that and handle all the dependencies as well. So let's welcome to the session. A little bit about me. This is as you already know, this is Pranjal Singh, and I am a certified Salesforce developer. I have certifications on PD1, PD2, and admin and platform app builder. And I have experience of close to 7 to 8 years across various phases of Salesforce development. So that's a little bit about me. Let's set up the agenda. So what we will be covering in this session would be 5 to 6 pointer. I will summarize it. The first point will be understanding what CI/CD is, what packages are, the definition, and the types, the generation, and we'll go through the ancestry and push upgrades, the unlock packages, entire development lifecycle, and at the end we'll cover the considerations, limitations, and some known issues that are there in packages. So let's start. So let's understand what CI/CD is. You all have heard about DevOps terminology, that it includes CI/CD. Later on, we are going to have some CQ as well, which you will feel that it's a missing piece, the quality aspect of it. But as of now, in layman's terms, if you have to understand what continuous integration is, continuous integration is, you can say, a team of developers doing their changes on a regular basis, and that gets seamlessly integrated into a version control system. That will be our source of truth. Doing that completes the CI part. This happens automatically and on a regular schedule. So this is continuous integration. What about the CD part? Now you have all the changes over time under a single source of truth. You have to segregate that into releases, and that release will be moved on to packages or a production org. That way we'll cover the CD part, or continuous delivery / deployment. Both are covered there. So all in total, CI/CD becomes DevOps process. Why we are going to adopt this process? What are we doing that was not happening earlier, or what advantages do we have over time? That we will cover in this one. First of all, the quality issues. We can define quality gates over time. These quality gates, we will check about the use cases in the release process. Earlier, you have to do it manually, or you will covering it through other separate process. A complete DevOps process should cover that part for you. The second part is having errors while you are trying to deploy do a deployment, and you're facing a lot of dependency errors or something. Those things will be already covered in the automation scripts, that, or maybe the DevOps, the way that it is being configured. And then there will be safe rollback options. Maybe you have proceeded and you have proceeded to a point where the last version was not working well. And how will you rectify it? You have the option of rollback safely without going through a lot of manual steps or another configuration. You don't have to do all those. You can directly one click, and you can go to the last version that was working fine. There is a smart integration. All of you might have faced this, that when you're trying to push a change, you get a git conflict, a merge conflict, something like that. And sometimes it's not that big of a change that needs to be fixed manually, but as of now, without CI/CD, that would not be possible. So there are tools which does this smart integration aspect. This covers it. The DevOps process will automatically cover and auto resolve it for you. So all the minor Git issues that you face, those will be auto resolved when you go with DevOps. Now, this entire thing, when we completely implement all these details, we get two strict advantages. The first is having a tight feedback loop. Now, whenever you are adding functionalities over time, pushing releases to the customers, now there might be something that is not working, or you face some issues, something went wrong, then In that aspect, you can quickly go through this entire process quickly rather than going through that earlier change sets, maybe and migration, all these things, will take much time than what you are trying to do here. And this in its entirety saves time, which is the faster release cadence. So the entire release process improves a lot and by drastically. So let's go into what we started, that Salesforce package. So let's go into the literal definition of what Salesforce package is. A package is an entity which holds all the metadata items that you have developed, modified, you want to push it to the next stage, that can be added into your package under a single container in Salesforce. That is just package. A package cannot exist without a version. So whenever you try to create something, it needs to be versionated, else it doesn't make sense. So there should be initial version, and then you can go through it on a particular format. Normally, there is a format that we use is the major.minor.build.version, like that. And the last point, that how this connects to the CD model, is it is immutable. Immutable, unchanging components becomes our artifacts for our continuous delivery model. So that's what what packages are. Let's understand the package-based development model. So you all know that there are two types of model that in a development in a project. While doing development in a project, there are two approaches to do that. One is the org-based development model, and another is package-based development model. Org-based, we all have already used it. The classic mode was org-based only. That you guys are working on DevOps and then pushing changes to QA, staging, and all those aspects. In package-based development model, the advantage is you can have scratch orgs where you can do your changes. Those changes will be merged into your source control system. And then the CI/CD system has automations on it, which will go pick all these changes, build on it. Then the testing will happen in the test phase, the staging plus UAT phase, and then we can have a release where the training and deployment happens. So modularity is the advantage here. It provides you more flexible options to have. You can have more customizations over time. You want to have more orgs in between, more staging you want to do, you can do it. Sometimes we need UAT1, UAT2. That is possible in this model. Also, this is breaking a monolith into multiple services, and they intercommunicate with each other. So this has all the advantages that you feel over the classic model that we use. Let's move on to what package types are. There are 4 types of packages. 2 we are commonly aware of, that is the managed and the unmanaged version. Pretty much managed package everybody has used at some point of time. The unmanaged package is the one which has all the less restrictions, but you still, it's not having the required flexibility to do some minor things, like it's not upgradable. If you prepare something in an unmanaged package, it's not upgradable. In that sense, the 2 different options that came up was unlogged and logged. The logged will not go through because that is not GA'd yet. I'll just give you a summary of what GA is. Maybe few folks might not be aware of it. This is generally available features in the release notes of Salesforce that every quarterly they came up with. They do not release it directly. They go through 2 phases: pilot phase and the beta testing phase. The pilot phase, they release it to some customers, or they try out who has who wants to try it. They can go through the test pilot phase. In beta testing phase, the subscriber have to subscribe to the beta testing aspect of it, and then they can explore the functionality. So that's when a feature is GA, then it becomes generally available for everybody in the while using the Salesforce. So unlogged is the one that we will cover in this aspect. Let's move. This is a sample screenshot that you can see. I think it might not be clear on the screen, but this is a beta version unlocked package sample that you will see in the org when you try to create it. So that's one helpful screenshot for you. Let's go on to the next one. So we'll go through the comparisons of what a managed package, an unmanaged package, and how unlocked solves more problems in between these 2. So managed and unmanaged, least restrictive and completely open, like least restrictive and the most restrictive options. Now unlocked provides you all the features of managed and without the missing features of unmanaged. So unlocked is the sweet spot between managed and unmanaged. The best flexibility that you have is you can do pretty much everything in unlocked apart from publishing it on App Exchange. So that's one restriction due to which it is not IP protected. So whatever you work on in a managed package, that becomes an intellectual property. And when you publish it on an App Exchange, you cannot see the code. You have to go through the support process and check out some issues that you're facing. So that problem is not a problem in unlocked, because we are not going to publish it. You have to go with managed, but unlocked provide you upgradable features. Even IP protection is not enabled, so that is a benefit for you because it opens up a lot of options. The namespace thing in managed is mandatory, but in unlocked you have this option of either not having a namespace, or you can want to have a namespace. Both are fine. And the one thing that you might have to take care of is unlocked. Right now you have to use Salesforce CLI. There is no UI. You cannot search it in the setup general for settings. You have to go through the Salesforce CLI commands in order to prepare a unlock package and explore it. So that's pretty much the difference. And I think it's you can just, if you want to understand it in a very broader manner, it will be unlocked does everything apart from App Exchange publishing. So that's one thing. Let's move on to generation of packaging. So Salesforce internally, so this is not internally how it is implemented is what generation is. People who have used, who are in ISV products, they might be aware of it, but 1GP is the older version from where we started. 1GP managed and unmanaged, the older version is 1GP. You can take it as a example of, in the telecommunication sector, we have 3G and 4G. It's that summary only. 1GP is the older one, and 2GP is the latest version that Salesforce wants you to move to and supports as well. A lot of features were lagging in the first generation, and second generation provides more additional features and as well as some flexibility that was not available earlier. Let's start with one by one comparison. Namespace in 1GP can be associated with only one package. Now, one package and one namespace is pretty much the standard. I hope everybody is aware of the namespace part. So namespace is a 1 to 15 digit identifier. When you have multiple packages, different multiple packages installed in a single org, how one app will differentiate from the other one. That identifier is the namespace. So in 1GP and 2GP, the advantage that you have over 2GP is you can have multiple packages and they can share the same namespace. So that's a huge leap from what we were able to do in the older one. Second is package versioning is linear. There is a format that we follow 1.0, 1.1, 1.2, and like that. When you want to move from the linear version, you can move to branching. Sorry for that. So breaking from linear to branching will be covered in Ancestry. So right now we can understand that 1GP doesn't support that. 2GP, you can break from the linearity, you can move into the branching. If you have some hot fixes, you want to have some patch releases, you need patch orgs that will be doing it for you in 1GP. But in 2GP, you don't have that restriction. In 2GP, you can, because there is no concept of patch orgs. You are using Salesforce CLI, you can pretty much cover everything. And version control is a source of truth in your 2GP format. 1GP was not supporting this, so that is like the older one. Yeah, I think 1GP will be supported for managed going forward, and then eventually everything will be 2GP managed and 2GP unmanaged, unlocked. Global Apex and the annotation. So older method was using a global namespace. That was the only way your code can be accessed in your entire namespace. Right now, putting classes as global is already, you are opening it up to all the risks that it comes with. But now in 2GP, you can have public tagging for the classes, and you can put the annotation namespace accessible to make it available across all the code that you have in your in that namespace. So 2GP has its own benefits: namespace, for multiple packages, no patch orgs, and the annotation with more security features. Let's move on to the next one. Okay, so package ancestry. So first of all, we'll understand what ancestry is in packaging. Package ancestry is nothing but moving from linear versioning to branching. This decision causes the package ancestry to come into place. Now, you can see at the screenshot, that's a package version from the CLI that we have taken. We have two tags that, first is the ancestor ID and second is the ancestor version. You will see that why do we need ancestry and how it is implemented. The implementation will cover is using these two only, but I will show you the next screenshot where I explain in detail what actually it is. So let me move this side and you can see the screenshot where I have all the versions defined clearly. You can see all the green ones are the ones that we did good and 1.2, 1.5 we messed up. So when you have messed up from 1.1 to 1.2, then you don't need to start from, if you're moving linear, you have to move from 1.2 to 1.3. But since Ancestry is there and 2GP is there, you can break from that linearity and move from 1.1 to 1.3. That means refer the last stable working version rather than fix. If you have to move from 1.2 to 1.3, you will have to go through patch logs, patch versions, all these changes. So you can skip that part. This is a very interesting concept, and this you will face only when you start going through a complex release process. When you have multiple packages involved, there are interdependencies, there are different releases you are doing, and then something happens, and then we can handle it like this. In a screenshot here, you can see you don't have to mention or remember the version of the because you are doing it every time. You don't have to get it the specific version hard coded here. You can mention the highest tag, and that will automatically spin up the latest copy from the last stable version. That is ancestor as well. So that is there. We have two CLI commands. One CLI command for checking the display ancestry. Display ancestry will give you a tree model in your CLI, where you will be able to see all this entire diagram that you see. You will be able to see the like this. I think I don't have that, but yeah, it's a CLI tree model in which you can see the version and from where this is branched into how many versions, and then data sub branching is done. All those details. Sometimes when you are working in your development, you don't want to make it that complex. You don't want to be have this dependency check, and you want to make it very easy. In that case, you can use the skip ancestor check parameter while creating your package, and that will take care that this ancestry is not implemented at that moment. Eventually, going forward in a complex setup, you need it, and this will be extremely helpful when you have when you want to be risk free. This is another example of releases. There are major releases, and the green ones are the patch versions. You can see the arrow key. The arrow key shows the ancestor relationship and the descendants from that particular ancestor that has taken place. We have gone through the entire thing. From the top is the initial version, and the last is the latest copy. Upgrading, when you are trying to upgrade from the last package, whenever the ancestry is followed, upgrading will happen without any error. But if you want to upgrade without any ancestor relationship, which happens in the last two highlighting, if you can see the red markings, these two are not related to each other using ancestry, and then it will be giving you an error that this cannot be done. So that is one limitation that you have to be careful while doing push upgrades when you are using package ancestry. Let's move on to the next slide. Unlock packages. So we have already covered the differences, but I will give you a little summary what unlock packages are. So it's a source-driven development in which the package is the source of truth rather than anything else. Whatever unlock package you have created a package, you have committed all the changes, your package becomes a reference point for the working version. There are two types of unlock packages you can work with. First is the org dependent. Another one is loosely coupled. Since the name is quite obvious, but org dependent, when you are using, you have to use it's a straightforward org dependent parameter that you have to pass while creating a package. So in that sense, org dependent has huge benefits when you don't want to handle the dependencies. So you might have a list of metadata items which are interrelated. You cannot create a new metadata because some other metadata is missing. In that case, you can create an org dependent one. In that, while creating, it will not give you any error about any dependency. Only when you are installing it, you are able to go through that check. In loosely coupled one, it is the way to go for complex setup, and you want to have more abstracted, more abstraction in place, more enterprise patterns you have used. You have used dependency injections. All these things you can implement to to further modularize the entire loosely coupled package. So rather than building a monolith, we break it into multiple small modules, and then we have services well-defined services that interact with each other. And then we have interface boundaries among these packages through which they can communicate. And loosely coupled becomes more complex because you have to handle all the dependencies. So you have to be careful going ahead with loosely coupled. And the diagram you can see, when you're creating a project, you create a DX project, develop the app, create that package, have that package version tagged to it, and then install and test it, promote and release the package version. And that's how the entire life cycle of an unlock package is done. Let's move on to the next one. So two basic things you need to remember while going for an unlock package. First is the Apex code coverage requirement. That's a universal mandatory rule in Salesforce to have 75% of code coverage. So in that case, what you need to do is only for except org dependent in loosely coupled, you have to take care of this code coverage requirement. Org dependent will not bother you about the requirement and you can bypass it. But in case if you don't want to use it in loosely coupled, you can skip validation, will bypass that check while you are doing it in the initial phases. So that is good bypass that is available. In order to get a report and get the stats of the code coverage that you have in org, you can use the code coverage parameter as well in your CLI command while creating the package. Just take care that sometimes when you're creating a package and if running test classes is a mandatory thing, then you have to be aware that the whole package creation process takes too much time. So just beware of that. Sometimes it's too much. And the second thing is a promotion. Promote a package version to release. This is a user permission for doing this. So that's a pretty much two aspects that you need to be careful about. Let's move on to the next one. So these are all the list of CLI commands and all the supported operations for unlock packaging. Creating the package, having a version tag to it, installing it, upgrading it, and the downgrading it, as well as uninstalling it. Here, I have not covered one aspect, that is the security part of a package. You can define an installation key flag, which you have to set true or false in order to put a password to your package. So that is very important that you have to take care. But these are the supported operations as of now. So push upgrades. Let me tell you about the push upgrades, because this is not a very common feature, I think. Not a lot of people are using it, but this is automatically upgrading your entire customers on the latest version that you have for your managed package. So what you can do is you can define, configure your orgs for push upgrades, and this will automatically happen without your consent. Once you have done all the prerequisites, what it will do, it will, at a particular schedule, it will update, keep on upgrading with the latest copies that you are releasing. So consider you have every month, new things are coming up in your package. Your version is 1.0. And automatically, if you have configured it correctly, automatically you will have, once the release 1.1 is available, your package will upgrade to 1.1. Very powerful feature and very interesting functionality, but you have to be careful that this does not succeed all the time. Sometimes you will, it's not 100% working one. You might face issues while doing it. Right now, you can define 500 subscribers, comma separated, all the subscribers who want to get the latest version, as well as you can exclude it. If you have some subscribers who don't want to be on the latest copy, it's okay. Maybe they have configured their orgs in such a way that their functionality might break with your latest version. So, be careful about it. This has its own pros and cons. So since the positives will be no support involved. Right now, we do not need anything because it's automatic. It's done. It's configured in an org. So you don't need a support reach out. Second will be you getting the updates with the predictable schedule, and patch versions are not needed anymore. This particular push upgrade, this is one particular automation that brings your packaging to the close to the continuous delivery model. You can see the gotchas are there, but the most important con that you will see is when you have interdependent packages in place, then this might be an issue. So you have package A, B, and C, and B and C depend on A depends on B and C versions. So you have to put a delay in order to you have to do it for B and C first, and then you have to do it for A. So that way it will be synchronized. There is no automatic synchronization as of now. So be careful. This is a very powerful feature. This will bring this packaging to the CD model that we want. You can see one restriction is you can make SOAP API calls with all these options that are available. You can check the status if it succeeds, if it is in process, or something, some error happened. Also, you can initiate it and check the subscriber org details as well as the package version details as well. So this is a pretty much standard 5 options that you have. I don't think there is a UI right now, but right now you can only do SOAP API callouts and get this done. So very interesting one. Let's go on to the demo. So this will show up all the metadata items that are not currently supported in packages. So not everything is available, but you can see on this URL all the metadata items that are currently unsupported in Salesforce. This is a real-time one. Maybe this list keeps on changing, but you have this options of 2GP packaging. The columns are there, and you can see that source tracking is supported or not, unlock packaging supported or not, 2GP, 1GP, like that. There are other options for old ways also, change sets, and doing it there. There are some known issues for each API that you can check from this org as well. So this is a nice, helpful URL that you can keep for reference. So from the perspective of generation, there are still 3 things that are not supported from Salesforce in 2GP as well. So those will be 3 things. There is no package versions that can be deprecated. So once you release the package, or once you have a version attached to it, you cannot deprecate a better version. Second thing will be Apex version provider isn't supported, and the most important, I think, is the default language for labels isn't specified yet. So that is these 3 things that you need to be aware while doing it. Multi-language, it will be an issue that you have to be careful about it. But maybe in the upcoming features, you will have this solved. So keep looking, and maybe 3GP will come. Who knows? So these are all the links that helpful resources that you can have reference from. These are good documentations that are available, sub blogs, wherever some useful blog that we have used, and then these are some useful resources that you can refer for more details if you want to go into different details into this. Let's have an unlock demo. What we have prepared 2 shell scripts in which we have defined multiple CLI commands. What we'll try to do is, you can see on the screen, I'll be on the side. So we will try to create a package and try to deploy one component from one scratch org to another. Right now, what you're seeing is a Bitbucket feature branch that we're creating. This is our version control from where we will start. We will have a add subtraction sort of class, Apex class created. And then we will pull this change into our editor. So we have prepared this script already so that we don't have to type all the commands. It becomes easier. So this script create scratch org, will spin up a scratch org, set the language for the user, and it will add this component. Like, it will see all these things that are there. You can see, and at the end, it will run Apex test for you. This is a nice approach of doing things, faster when you have repetitive, you have to go through repetitive commands. Each time you have to go through the VS Code editor options. Rather than that, you can go through some automation scripts. If you want, we can have it on a reference, and maybe Anmol can share you later on. So you can see that a scratch org is being created. This might take some time, but yeah, it will perform three operations for us as of now. So now the changes are being pushed to the scratch org. You can monitor the log. So one component from feature branch is being pushed to a newly created scratch org. See, you can see the calculator classes that are there. We are running Apex tests just to be safe, because while preparing it might be a restriction. It might take some time, guys. So yeah, let's see. We're trying to do a quick change. The tests normally take not take that much time, but please hold with us. Demos are not always smooth. Okay, so we have test run correctly. Now we will try to create the package, the unlock package. Can you have can we have the package open? Yeah. So this is the script. You can see, what we have done is just put all the parameters that needs to be passed before setting in the final command, the package version, the package name, create with the package tag. We have bypassed the installation key. That is a mandatory thing in order to avoid, putting password, so that you are aware that, it's a passwordless packaging that you're trying to do. And now you can see this execute sfdx install command last will install this package after having this created. So these are all the prerequisites that we have defined for aliases, like different orgs that we are trying to do. Breaking into different components is always helpful. Now we're trying to open the org where we have done this change. Are we the right tab, Anmol? Yeah, it's loading. Okay. You can refresh this page. I think it's stuck. Yeah. Yeah, it's just hard. Live demos are infamous, guys. Please hold with us. And you can see the install package that right now that we created with the component that we added. You can see that this is the one that we created from our scratch org. This one. you can see the version is automatically tagged for a beta version. And by default, it has taken a 0.1 format. We are the publisher, so it's marked as self, and all the other parameters you can see. So this is how, it's automatically installed, and we have shortened it in a script because we don't have to type it, and you can see, it shortens our time. But this is a sample of how you can configure your scripts in order to have multiple commands to work on unlock packages very quickly. You can see the JSON file where we haven't put a namespace. So that was an optional. And you can see we can blank it out and it works is fine. You can, whatever aliases we have defined, that is tagged, and all the versions, all the other parameters that have defined, that is there. You can see the version name and number. You can have .next defined, which will automatically pick up the latest version in your build. So this is a very important feature. You don't have to remember all the time the version number that you are on and you have to move to. It's a very nifty and very cool feature that they have. So that's the, I think, demo for you guys. And we can switch back to slides. So, sorry, you have any questions? Please throw at me. Anything? You can ask any questions. You can ping me later also. I'm here, so it's fine. You can come up with some questions. I'll be there to answer. But yeah.
Yeah, I have a question. Yeah.
Okay. Yeah.
Yeah. So are both unlock packages and 2GP packages are same, or is there any differences in unlock packages and 2GP? Because 2GP will be creating it from Salesforce, will be not logging into any org and create the package. So is it same like unlock packages or
2GP and unlock, right?
Yeah.
So yeah, no, these are not different. So generation is just the way they are trying to do it, but unlock 2GP is the way to go. Actually, unlock supports 2GP, and unlock internally is implemented using 2GP. So the older version we had was 1GP managed, 2GP managed, and 2GP unlocked.
Okay.
So 1GP managed is need to be there because you already have a lot of implementation and app exchange products that have been rolled out. So you cannot remove that feature, else they would have completely rolled back to, rolled forward to 2GP1.
Okay. Yeah. Because in 2GP also we won't mention any namespace or anything.
Yes, that's correct. So we have that option of having either having it or not having it. But in managed case, I think you will have to have it.
Yes. Yes. Yeah. Okay. Yeah.
Anybody else? Any questions for me? Okay. No questions? Perfect.